Hi, welcome back to Moose and Chemistry. This is electromagnetic spectrum lesson. The electromagnetic spectrum talks about energy and its wavelengths. Okay, but what is a wavelength? Well, a wavelength is measured from the crest of one wave to the crest of another wave, and it's denoted by the symbol lambda. All right, the wave height is known from the crest to the trough, which is the bottom of the wave, and that's the wave height. The frequency of the wave is the number of wavelengths that pass through a given point in a second. So if you look right here, you can see these wavelengths going through this given point by this line. And the number of those wavelengths that pass through that single point is known as the frequency. Right, different wavelengths have different capabilities. Long wavelengths are on the right side of the equation, so they have lower energy. Shorter wavelengths are on the left side of the spectrum, and they have higher energy. All right, the lowest wavelengths are AM radio waves. So AM stations, those radio waves can't even bounce out of the atmosphere. And so if you listen to AM radio waves, they often have static in them, and that's coming from interference from the sun on the ionosphere. FM radio waves can penetrate the atmosphere, and we can talk to satellites out in space and people even walking on the moon. Well, as we shorten the wavelength, we get to TV spectrum. So TV wavelengths are just above FM radios. And above TV, we have microwaves, and microwaves are what we use to cook our food with, our cell phones, and other types of communications. Okay? And they have a shorter wavelength than TV. Even shorter than microwaves, we have infrared energy. Now think about this. When you go to the beach, for example, and you lay down in the sand and you close your eyes and turn your face towards the sun, you can feel the warmth of the sun. That is infrared energy. Visible light, which is this light that we see from our sun, is also known as white light. But when it passes through a prism, it breaks into Roy G. Biv, which is red, orange, yellow, green, blue, indigo, and violet. And notice that the wavelengths are going from 700 nanometers to 400 nanometers. So the wavelengths are getting shorter and shorter and shorter. Right above visible light is ultraviolet light, or UV rays. And we have to be really careful with UV rays because that's another type of radiant energy that comes off the sun. And it tans us, but it can also cause skin cancer like melanoma. And just to give you a hint how dangerous UV light is, think about this. If you compress the wavelengths just a little bit more, you get X-rays. And X-rays are very powerful, and they can actually see through flesh. They can see your bone structure. And then if we compress X-rays even more, we get gamma rays. And gamma rays are what we get from nuclear reactions and radiation. Now, there is a formula which we do use to talk about wavelengths. And that formula is C equals lambda V. So if we want to calculate wavelengths, we rearrange the formula to lambda equals C over V. And if you want to find the frequency of the wavelengths, you just take V equals C over lambda. C stands for the speed of light, lambda stands for wavelength, and V stands for frequency. Okay, well that's it for this lesson. You guys be snarly, and we'll see you back here at Moose and Chemistry.